Hi, good afternoon, everyone. In, this is Dr. Rajkumar, Associate Professor, Department of Computer Science and Engineering. Uh, in today's lecture, in week one, we are going to talk about the introduction part of computer architecture, and we are going to mainly talk about the computer generations, classes, and the components of a computer. And then we talk about the computer architectures and the great ideas in computer architectures. And then we finally perform the what are the we talk about the basic performance of computer architecture. So, what is a computer basically? So we can say that computer is just an electronic machine that can store, find, and arrange information. And based on that information, it can calculate, the computer can calculate certain amounts and control other machines too. So the basic structure, it looks like the computer consists of the PPT. We say that the central processing unit, CPU, and another one is memory unit, and another one is the input output devices. So in central processing unit, we also say this as the heart of a computer. So that is consists of the registers, the small amount of memory which is used for processing purpose of processing the data, that is registers, and whatever data is there in the registers, that data will be fetched and utilized by the another unit in CPU called the arithmetic and logic unit. This unit is used for the computational purpose, computing the data, and then the data which is transferring from register to arithmetic and logic unit and arithmetic and logic unit to registers, that will be controlled by a separate unit called the control unit. And most of the data in the computer, that is in the form of the zeros and ones, that is always stored in a memory. We call that memory as your the primary memory and secondary memory, we used to say. But in generally, this memory on the motherboard of your computer, we call this as a dynamic random access memory, or DRAM memory. So then the data sometimes is supplied from outside the computer. For that, it needs an interface. So that interface, we used to say the input output interface, and which is controlled by the input output controller. So what are the input and output devices which are normally connected with this computer, that we can say is one is your hard drive or USB drive or DVD drive. These we can say that these are the uh, the memory devices, and the mouse, keyboard, monitors, and printers. They are, these devices, we can say that input devices which can supply the data. And sometimes the computers are going to be connect to each other. So for that, they required a certain interface we call the network interface. So network interface card will also treated as your input output devices. Another one is instrumentation robotics. So this is the overall picture of your computer. The computer can be looks like, the desktop. It may be your laptop. It may be your, the mobile. So these are different devices are there, right? So then we need to talk about the when this computer system started and what is the generations of this computer. So let us talk about this generation of the computer. So the computer, before talking to that one, during the evaluation time of these computers, the development period of electronic computing technology is called computer generation. And there are five generations of computers identified, although the sixth generation could be in development now in the early 21st century. During the evaluation timeline, each generation of computers has improved a lot by undergoing considerable changes in their size, type, and functionality. So, by analyzing them, one can trace the evaluation of computer technology to see how the computer industry has changed over the years and how great compatibility and software progress has been made by the humankind in under 100 years. As a result, the creation of different generations. So at present, the computers is playing an significant part in human existence because today's digital computer is being used for every work in each field. If someday an issue occurs in the computer or the server is down, at that point all the work stops. So this is how significant it is for technology development. So in this slide, we try to, or I will introduce you all the generations of computers with pictures by explaining the complete information about their characteristics, names, and the components. Okay, so first you can see uh, we start with the first generation. So the first generation of computers was based on vacuum tube technology used for calculations, storage, and control. Invented this first generation computer was invented in the year 1904 by John Ambrose Fleming. The vacuum tube and diode valves were the chief component of the first generation computer. So, the first generation computers relied on the lower level machine language in order to perform operations and could only solve a single problem at a point of time. So for storage purpose, the magnetic drums were used as the memory in these computers. The punched and magnetic tapes were used for the input and output functions of the computer in order to display on prints. Even the results were 100% accurate. Also, the first generation of computers available was based on the 8-bit microprocessor. The disadvantage of first generation computers are that they were very enormous in size and heavy in weight, made of thousands of vacuum tubes and occupying large rooms. Also, once they were kept in one place, it was difficult to transfer. So, another con like using a decimal number system, and many switches and cables. So, in addition, they were also very expensive to operate with using a large amount of electricity. The vacuum tubes produced large amount of heat, so as so an air conditioner was required for the proper functioning. Unless a lot of heat can cause a malfunction. The advantage of the first generation of computer is that they could calculate in milliseconds, about 5,000 sums per second. So the computers of first generation were managed to use in different fields like weather forecasting, solving mathematical problems, energy tasks, also in space research, military, and other scientific tasks. So, in the first generation of computers, the first computer of the world name ENIAC, we call electronic numerical integrator and computer. What we call ENIC. In the first generation, we call this ENIC. Right? So this is something about the first generation. Now we talk about the second generation. What are the improvements happened in the second generation? Right. So the second generation of computers replaced the vacuum tubes with a reliable component called transistors. With a reliable component we call the transistors. Transistors. Right. So these transistors are used for the manufacturing of the computers, and that was invented by William Shockley in the year 1947. The year 1947, the transistors were the revolution in the computer field because this component advantaged the second generation computer by increasing the performance, operating speed, so that is the hundreds of thousands of operations per second, and as well as decreasing the electricity consumption of the computers. So transistors were far superior to the vacuum tube and allowing computers to get faster, cheaper, more energy efficient made and possible to reduce the size of computing equipment and ultimately heat reduced and reliability improved. So computers of second generation are characterized by the use of the first high level programming language, allowing programmers to specify instructions in words. At this time, early version of COBOL, ALGOL, Snowball, or Fortran languages were developed. So there were the first computers to store their instructions in their memory, which went from a magnetic drum to magnetic core technology. So during this period, the first computer game named Space War was seen on the PDP-1 computer. So also the concept of central processing unit CPU, multi-programming operating systems, programming language, memory and input and output units were developed in the timeline of second generation computers. So this is the beauty of means from vacuum tube to from vacuum tube to it is transferred to the second generation. In second generation we follow the transistors. Because of that we are finding CPU, you can see the memory, you can find the input output devices, you can do the multi programming, right? So these are the the advantages of your first generation. You can clearly see in the picture the first generation is occupying the entire room, but whereas the second generation is reduced and made up of the transistors. Now we talk about the third generation. In the third generation, the, the third generation of the computer, so this third generation of computers appeared in the form of integrated circuits. In the form of integrated circuits. So here is vacuum tubes. Here is transistors. And when it reached to third generation, it becomes ICs. We say integrated circuits. Integrated circuits. So the integrated circuits are used, and that was invented by the Jock Kilby from 1958 to 1964. So an integrated circuit is consist of many small transistors mounted on chips, which are called semiconductors. So this synchronized chip become an important foundation for the third generation computers when scientists combined hundreds of transistors to fit in this circuit result in a more powerful electronic segment called an integrated circuit. So multiprogramming was implemented at the same time that it demonished their manufacturing costs. In the mid 60s, IBM improved the term computer architecture. By the end of the 60s, mini computers appeared. So this revolution involved allowed to expansion of the processing capacity and the memory of the machines. So instead of punch cards and prints, users interacted via keyboards and monitors and interacted with an operating system, allowing the device to run various applications at once with a central program that monitored the memory. So it was used in the system 360 series. The model had a vector monochrome display measuring, that is 12 by 12 inches, with a resolution of 1024 by 1024 pixels and a refresh rate of 40 hertz. So this invention revolutionized in today's different type of monitors, including LCD, LED, OLED, and the curved shade monitors. So the characteristics of third generation of computers. In this generation, computers based on integrated circuit was more powerful than the transistor. The size of the computers was likewise a little because the size of the IC integrated circuits being more modest than the circuit size of transistors. So more reliable, the third generation computers are more reliable, inexpensive, faster, energy efficient, as well as very light in weight than second generation computer. So the first computer mouse and keyboard were appeared and used in the third generation of computers. So use of new version of a high level language like basic, COBOL, snowball. So the programming languages uh, which is used, basic, COBOL, or snowball, Fortran. So these are few languages which are used, and here in the picture you can see the keyboard and mouse were used in the third generation. Okay, so now we talk about the next generation, that is fourth generation computer. So the fourth generation computer happened, in the period of 1971 to 2010, 2010. The microprocessor brought the fourth generation of computers as thousands of integrated circuits equivalent to build millions of transistors were assembled and brought the whole central processing unit and other fundamental elements of machine into a small chip called microprocessor. So from ICs it is reached to fourth generation with the microprocessor. The microprocessor. So that is the advancement of your third generation, right? So then these computers, the fourth generation computers, used very large scale integrated circuits technology, also known as VLSI technology. After the invention, the microprocessor began to use in computing machines in the fourth and fifth generation of computers. So within the framework of considered generation in 1971, the first microprocessor appeared as an unexpected result of Intel's work on calculator circuits and further development of microcomputer, that is PDP 11. So the first personal computer and a microcomputer was Altair, developed by the company MITS in 1974. Also, the first microprocessor was the Intel 4004. The first microprocessor was the Intel 4004 was the first microprocessor, and this microprocessor was manufactured in 1971, Intel 4004, and initially for an electronic calculator. So whereas the computers of the first generation filled an entire room, while now the fourth generation microprocessor fit in the palm of hand. So this generation of computers used an operating system based on the graphical user interface GUI, which means these numbers were very easy to perform mathematical and logical tasks. So the computers started to utilize the high-speed memory system on integrated circuits with a capacity of several megabytes. Computer performance has increased significantly, that is hundreds of millions of operations per second. So the high level languages like C, C++, Java, PHP, Python, Visual Basic was utilized to compose program in the computer of fourth generation. The advent of the first personal computer in the mid 70s gave every common user the same computing resources that enormous computers had during the 60s. So these computers were made more modest, faster, and less expensive can undoubtedly be put on a task or desk, which marked the so called era of personal computers. Right? So now let us see the characteristics of fourth generation of computer. The computers based on microprocessors and VLSI technology, as said, the computers of fourth generation were small in size, lightweight, and almost portable computers. The fourth generation computers are integrating of multi-core in processors like dual core, octa core, etc. has begun. And next characteristic is the processing speed of this computer generation was much faster and reliable than the previous three generations. The size and cost of power supply units has reduced, and use of languages like C, C++, .NET, Java, PHP, Python are Visual Basics, and the fourth generation use of graphical user interface, that is GUI based operating systems with more memory capacity and accessible to the internet, and due to the low cost of these computers, they were available to every common man. So this is about the fourth generation, and then comes to the fifth generation of computer. In the fifth generation of computer, it started began in the period from 2010 to at present. So the artificial intelligence is the name of the fifth as well as the latest generation of computer based on ULSI, ultra large scale integration technology, is the process of integrating or embedding millions of transistors on this single the silicon microchip. So here, if you see the characteristics of fifth generation, it main focus on AI based computers. The computers made of the microprocessors based on ultra large scale integration technology. The processing speed is quite high, can perform billions of calculations in a second, and computers are portable, cheap, reliable, fast, and available in various forms and realize like a desktop, laptop, smartphone, smartwatches, etc. And this fifth generation of computers, invention of the operating systems such as Windows, Macintosh, and Chrome OS of Chromebooks. So multimedia has evolved in this generation by combining sound, graphics, or pictures and text. So development of Internet of Things is also happening in the fifth generation of computer. So this is the something about the first to your fifth generation computers. So here use the ultra large scale, the VLSI is using. So these are the fifth generation. If you see the transistor in terms of memory, here vacuum is used, here the transistors are used, here the integrated circuits are used, here VLSI is used, very large scale, the circuits are used, and here the ultra VLSI is used. Sorry. Okay. So next we talk about uh, the classes of computers. The classes of computers, we can say that the portable devices we call the personal mobile devices, PMD. So these portable devices can be easily carried by any of the user. So that the examples for this one is start the smartphones, tablet computers, and this emphasis on the energy efficiency and real time. And the second one the desktop computing, that emphasis and price performance in this case. Then the servers, then these servers emphasis on availability, scalability, and throughput. Then clusters and warehouse computers. So these clusters are warehouse, scale computers, also known as your software as a service source, which emphasizes on the availability and price performance. And the subclass of these clusters are the supercomputers, that emphasize the floating point performance and the fast mathematical. And in nowadays you are saying Internet of Things is another, the part of the computers. Right? So then the classes of computers. The class of computers is, the computers are classified based on the five characteristics. One is personal, desktop, servers, the cluster warehouse, and embedded, as we seen in the previous the slide. So based on these features, the computers are classified. So the personal mobile devices (PMDs) are classified, are featured as PMD, that is based on the price of the system, price of microprocessor, and the critical system design issues. So the price of the mobile devices that lies in between $100 to $1,000, and which are the more energy, in terms of energy, it requires less electricity, very fast for computing, and easy to carry. Okay, and the price of microprocessor in these mobile devices, that exist in between $10 to $100. And the critical system design issues is the cost, energy, media performance, and the respectiveness. Similarly, comes to the next class of computers are desktops. Desktops, their prices lies in between the $3,300 to $2,500, and the microprocessor cost is $50 to $500 in existence. And in terms of the critical system design issue, the price, the performance, energy wise, and graphical performance are there. And similarly, for servers, it gives a very good throughput, and its availability is required, and the scalability is also possible by adding the additional the servers, and the energy consumption is also low here. And similarly, the clusters are the warehouse scale computers. So the critical system design issues here is the price performance, reducing the cost of the price, and increase the throughput, reduce the energy, and the proportionality. And comes to the embedded one, here also that system design issue takes reduce the price, reduce the energy, and increase the application specific performance. So based on these, the computers are classified into five main streams, that is five mainstream computing classes and their characteristics. So then we talk about the components of a computer. In the very first slide, we were talking about the components of the computer. But remember, the three basic components of the computer, which should be one should remember. One is CPU, central processing unit, and the memory unit, and the input output device unit. So some components for all kinds of computers, like it may be desktop, it may be server, it may be PMD, personal mobile device, it may be the cluster warehouse. Okay, so every device, they require this CPU, memory, and the input output devices. So two core parts of the computers we call the processor and the memory. These are very important. Based on these two, the computer's price increasing and decreasing will be there. So the processor and the memory, as we say, the central processor and the memory, right? Then comes to the another part is your input output. So that input output, which includes the user interface devices like display, keyboard, mouse, and the storage device, external storage devices, we used to say, that we call the hard disk, CD, DVD, flash. And when your computer is connected with other computers for sharing the information, the network adapters are required for communicating with other devices. So another part which exists in this input output devices is network adapters. So then inside the processor, we say inside the CPU, what are the main components are existing that we see. One is the functional unit, another one is the data path, control logic, and cache memory. So inside the central processing unit, first one is functional units, data paths, and the control logic and cache memory. So functional units are used to perform the computations, all the arithmetic and the logical operations are going to be performed using the functional units. So operations, to perform the operations, data should be supplied. To transfer the data from one unit to another unit, the data path is required, which is the wires for moving the data from one unit to another unit on the CPU. Then the logic control. So these logic controls are used, and they are the sequence of data paths and memory and operations. Sequence of data paths, memory, and operations. The means to perform any operation, it requires a data. So that data comes from the memory. So in the memory, from one memory hierarchy to another memory hierarchy, the data should be transferred. So for that, it requires the data path wires. And then what are the, to make the system faster, it requires the internal, the small amount of memory. We call it as your cache memory. So this cache memory is a small, fast SRAM, the random access memory, static random access memory, for immediate access to the data. So here in this diagram, you can see the Intel 386 based processor architecture. So in this processor architecture, you're finding the CPU, the central processing unit. The central processing unit is connected with the QPOOL, and it is connected with the ICUs. Okay, so here you can see in these are the cache memories. We say L1 cache, L2 cache, L3 cache. Here is the L3 cache, here is the L2 cache is there. These are the cache memories. These cache memories exist on the central processing unit itself. These QPOOLs, these are going to store the instructions in a queue to perform it. Then the instruction decoding unit will be there. So that we are going to discuss one by one the inside that. And to carry the data from one unit to another unit, you find the bus interface units, buses we call. So here everywhere you can find the wires which are used to carry, or we say the data path, to transfer the data from one unit to another unit. Okay. So then comes to the next part is memory. So the memory, we are going to discuss only the broad here. The memory is, one is volatile memory, we call the temporary memory. Another one is non-volatile memory, or we say the temporary memory and permanent memory. So the volatile main memory, we call this RAM or DRAM or SDRAM. So this loses instructions and data when power off. And the volatile main memory is fetching and storing of data are very fast and economical in volatile memory. So as soon as power goes off, all the instructions and data will be lost. Whereas in non-volatile, these are permanent. We call these as your, the secondary memory also. So these are using the magnetic disk or flash memory or CD-ROM or DVD or hard disk. So these are all comes non-volatile secondary memory. They looks like the volatile memories looks like here the RAMs and the microchips, whereas your permanent memories looks like this one. And these memories are exist on the central processing unit. In central processing unit, these are the functional units, but after that the memory unit will be there. In this memory unit you can find the volatile memory and non-volatile memory. In volatile memory you can find the cache memory level 1, level 2, level 3, and then all the registers that you can find here. Okay, so with this I would like to stop this session, today's session, and we'll continue this session in the next lecture.